Today we will present fiber optic communication system problem-based task. This is our group member, me, myself, ALIF, HAZIRAH and VOUNICA. Next, I will pass to VOUNICA.
So I'm gonna present for question 1, which the question is study the reflection of light by face, mirror, and refraction. So A is reflection, which is when light traveling through air encounters a different material, part of the light energy is reflected back into the air, shown in figure 1. So here is the experiment. There are hypotheses, apparatus and materials, and also the procedures. So we will measure the angle with respect to the 0-degree line. All the angle measurement will be in range more than 0 degree and less than 90 degrees. The light ray at normal incidence to the flat edge of the mirror will be start first. Next, we will proceed from 0 degree to 90 degrees in 20 degrees increments, each time recording the angle of reflection. Next. Next slide. Okay, so here are the results. For angle of incidence 10 degrees, sin I, we got 0.174. Angle of refraction will be 6.55. Sin R will be 0.114. For angle of incidence 30 degree, sin I is 0.500. Angle of refraction will be 19.20 and sin R will be 0.329 and so on for 50 degree, 70 degree, and 90 degrees. So we provide the calculation here. We use formula N1 sin theta 1 equals to N2 sin theta 2. For N1 is A, which is the index of incidence 1.00, and N2 is glass, which is the index of refraction 1.52. So we just put the value into the formula and got the answer. So for B is refraction. Figure 2 shows an incident ray traveling from A to material X. Find the refractive index of material X. So for this question, we use the same formula, which is N1 sin theta 1 equals to N2 sin theta 2. For N1 is NA, which is the index of incidence is 1.00. For N2 is material X, which is unknown, and theta 1 will be 40 degrees, which is the angle of incidence, and theta 2 will be 30 degrees, which is the angle of refraction. So we just put the value into the formula and got the answer. Material X, the index of material X is 1.286. 286. So for B refraction in question 2, in an experiment, a ray of light is directed towards the surface of water at an angle of incidence of 50 degrees. If the refractive index of water is 1.33, calculate next slide. Okay, so calculate the angle of refraction. So from the statement above, here is the information we collect, which is index of refraction is 1.33, angle of refraction theta r, which is unknown, and the index of incidence will be 1.00, angle of incidence will be 50 degree. So for first, we use formula N1 sin theta 1 equals to N2 sin theta 2 to find the angle of refraction. And then we put the value into the formula and got the angle of refraction 35.17 degree. Next, calculate the velocity of light in water. We use formula N equals to C per V, which is C is the maximum velocity of light, stated 3 times 10 power of 8 meter per second. So N is the refractive index of water, which is 1.33. So we put the value into the formula and got the final answer is 225,563,909.8 meter per second for velocity of light in water.
Next, I will continue the slide for question 2. Wavelength division demultiplexer is one of technique in optical frequency division multiplexing. Explain the concept of WDM and build WDM block diagram. WDM is one of the method that technology used to multiplex the number of optical carrier signal into single optical fiber using different wavelength. For example, using different color of laser light. This is WDM block diagram. From the transmitter, which is have different wavelength, which is signal 1, signal 2, signal 3, and so on. And the signal will go to and flow through multiplexer, which is convert all signal into different wavelength to travel in fiber optic. In the middle is data travel in different wavelength, which is one way. Before go to the transceiver, the signal will go to the multiplexer, which is convert the different wavelength to the signal sent.
A PUAN, which is passive optical network system utility splitter that takes one input and splits into broadcast signal downstream to many users. Illustrate basic PUAN architecture. Terminate diagram with different type of fiber to the loop. FTTF. So this is a PUAN architecture diagram. On the left side, we have PSTN, Internet, IPTV. So the Internet go through the optical line terminal, which is OLT. OLT, which are the central office of the passive optical network, and so on. The pass through passive network splitter and got divide into two group, which is optical network terminal ONT and optical network unit ONU. On a optical network terminal, we have divide two groups, which is FTTC, fiber to the curb, which is outside the building, and FTTN, fiber to the node. So, and the optical network unit ONU have FTTH, fiber to the home, and fiber FTTB, fiber to the building. That's all from us. Thank you.